Assalamu alaikum and a very good day to everyone. Today we are going to discuss an important application of integrals known as cylindrical shell method. This method is used to find the volume of a solid of revolution, and it is especially useful when the disk or washer method becomes very complicated. By the end of this lecture, we should be able to understand what the shell method is, when to use it, and how to apply it correctly. So, now we are going to delve into the concept of the cylindrical shell method. It is a technique for finding the volume of a solid of revolution when integrated the volumes of cylindrical shell. It is actually used to find the volume of the surface when it is rotated about any axis. Instead of slicing perpendicular to the axis of rotation, like we use in this method of washer method, we slice parallel to the axis and form thin cylindrical shell. Let us understand it through different images. In the first example, we are given a surface which is known as y is equals to 2. If we revolve it around x-axis, then it will form a cylindrical shape like this. Moreover, in the second example, we are given a curve of y is equals to x, and when it is revolved around the positive x-axis, then it will form the shape something like this. And in the cylindrical shell method, we were able to find the volume of this surface. Moreover, in the third example, if we are rotating a curve about the x-axis whose value is y is equals to square root of x, then it will appear something like this, and through cylindrical shell method we will find its volume. In the fourth example, if we are given a semicircle and we were asked to find its area when it is revolved around the y-axis, then it will appear something like this, and by using the cylindrical shell method we can easily find its volume. While dealing with the cylindrical shell method, we have to keep one point in mind, and the point is that if the surface is rotated about the horizontal axis, then we integrate the whole expression with respect to the dy, and if the surface is rotated around the vertical axis, then we integrate whole expression with respect to dx. This is a very important point in the cylindrical shell method, and the point is quite opposite in the disk and washer method. So now we have to derive its formula, and its formula is 2 pi integrate. We have to integrate radius multiply its height. Height becomes the expression which we are given, and radius is about the axis which we are dealing through. So we know that radius multiply height becomes the area, and if we integrate the area, then its unit will be cubic unit, and it gives us the volume. Surface is rotated about y-axis, then we take x into f of x. But if the surface is rotated about x-axis, then we take y into g of y, where radius is the distance from the axis and height becomes the function value, the original function which we are given. First, let us understand it through different examples. First is its basic application, in which we are asked to find the volume when the region bounded by the curve y is equals to x square, y is equals to 0, and x is equals to 2 when it is rotated about y-axis. In this case, if, as I have discussed below, if it is rotated about vertical axis, y-axis line is the vertical axis, then we integrate our expression with respect to dx. Just like in the example, we are integrating the expression with respect to dx, and in this case, the radius becomes x, the axis through which we are dealing, and the value of expression which we are given, which is x square, and it will be x cube, and if we integrate it from 0 to 2, then the answer will be 8 pi cubic unit. Let us understand it through a visual example. In this curve, we are given y is equals to x square, and we were asked that it is rotated about y-axis. So in the 3D view, it will appear something like this. And in this example, 8 pi cubic unit, we have found the area of this surface. Now, in the second example, we were asked to find the volume of the curve y is equals to square root of x between 0 and 4 when it is rotated about x is equals to -1. The line x is equals to -1 is making a vertical axis. So if the surface is rotated about vertical axis, then we integrate our expression with respect to dx. Just like in this example, we are integrating with respect to dx, but here is a minor change in it, that we are not said that it is rotated about y-axis, but instead we are said that it is rotated about the line y is equals to square root of x. So in this case, the radius will be x minus the value about which the line is rotated, which is -1. So original value of the radius will become x plus 1, and the height will remain the same because it is the value of the function, which is square root of x. And the boundary region is from 0 to 4. If we integrate it, then the final answer will become 544 pi divided by 15 cubic unit. As it is a value of volume, so its answer will always be in the cubic unit. And here is the visual representation of our question, in which we are given the curve y is equals to square root of x, and when it is revolved around the radius x is equal x plus 1, then it will form a curve something like this. Now, in the third example, we were asked to find the volume when the region is bounded between two lines, one of which is y is equals to x and other is a curve which is y is equals to square root of x. And we were said that it is rotated about y-axis. Y-axis is the vertical line, so we integrate our expression with respect to dx. Just like in this example, we are integrating with respect to dx. In this example, we are given a line and a curve, so its height will be f of x minus g of x. First value is x and we minus it from x square. So the height will be x minus x square, and as the surface is rotated about the vertical axis, so the radius will become x. We multiplied radius into height, so it will be x into x minus x square, and the bounded region is between 0 and 1. When we integrate it and multiply it by 2 pi, then the final answer will become pi by 6 cubic unit. Here is a visual representation of our question, in which we are given the curve y is equals to x square and the other line which is y is equals to x, and the radius is x because it is rotated about y-axis. And the answer, which is pi by 6, is actually the answer of this surface volume, in which I have represented in the 3D view. Now, in the fourth example, we were asked to find the volume when it is rotated about the region bounded between x is equals to y square, x is equals to 0, and y is equals to 2 about x-axis. X-axis line is a horizontal line, so in this case, we will integrate our expression with respect to dy. As in this case, we have integrated with respect to dy. The value of function is y square, and the radius in this case will be y because we are dealing with the horizontal axis. We are integrating it from the region of 0 to 2. So the final answer of our volume will become 8 pi cubic unit. Here is a visual representation of our question, in which we are given the curve x is equals to y square, and we were said that it is rotated about the x-axis. So in this case, this is a visual representation of our curve, which is making an angle of 30 degrees with the positive x-axis. Now comes the common mistakes to avoid. Many students drive the answer, but they forget to write 2 pi in their answer. That's why they will get the wrong answer. Everyone should remember to apply 2 pi in the formula. Most of the students take wrong radius, especially when it is given as the line. Just like in second example, we were given the line of y is equals to minus x, x is equals to minus x. Many students do not understand this line, and they put wrong radius in their question. Incorrect height, wrong variables, and last comes the integration bond. You should carefully apply the integration bond, because otherwise it will give you a wrong answer. This is your practice question. In this question, you are asked to find the volume when the region bounded by the curve y is equals to 2x minus x square, y is equals to 0, and it is rotated about y-axis. Y-axis is a vertical line. As our curve is rotated about a vertical line, so we will integrate it with respect to dx, and the radius will be x because we are dealing with the dx, and we multiply it by the height, which is 2x minus x square. Kindly solve it and answer it in comments. Moreover, comes the summary of my topic, which is cylindrical shell method, in it is used to find the volume. It uses cylindrical shells parallel to the axis of rotation, and its formula is 2 pi integration of radius into height. Radius is the distance from the axis of rotation, and height is the function value or the distance between the curves. It is very useful if the disk and washer method are difficult. Then we find the volume with respect to by using the cylindrical shell method. Thank you for watching this video. If you like this video, then don't forget to like and subscribe my channel.